these new trends toward opening far larger bands for unlicensed shared public access, as well as these dynamically shared bands, such as the Citizens Broadband Radio Service, taken together, we will have, I think, transformed what's perceived to be spectrum scarcity into spectrum abundance.
Hello, this is the Community Broadband Bits podcast from the Institute for Local Self-Reliance. I'm Lisa Gonzalez. Using our electronic devices without being tethered with a wire has become more mainstream. Expanding that wireless connectivity depends on the availability of spectrum and careful spectrum policy. Michael Calabrese, director of the Wireless Future Project at the New America Foundation, joins Chris today. They talk about the difference between licensed and unlicensed spectrum, uses for both, and how new approaches can optimize this valuable resource. Learn more about Michael's work at newamerica.org/OTI. Now here are Chris and Michael digging into spectrum and the wireless future.
Welcome to another edition of the Community Broadband Bits podcast. I'm Chris Mitchell, and today I'm speaking with Michael Calabrese, the director of the Wireless Future Project at the New America Foundation. Welcome to the show.
Yeah, thanks, Chris. This is great to be part of your podcast.
Well, I'm excited to be talking to you. You've been in this space far longer than I've been working on community broadband. I think the expertise you bring is quite high. But let's start with you telling us a little bit about what is the wireless future and what kind of work do you do?
My Wireless Future Project is part of New America's Open Technology Institute, which is really about all things open open networks such as net neutrality, open technology, open airwaves, and I focus on the wireless side. And for over a decade, we've been really promoting policies that will result in ubiquitous, high-speed, and affordable wireless connectivity for all Americans and hopefully globally as well. And kind of at the forefront of that has been to open more spectrum for unlicensed access, that is, shared public airwaves, and also dynamic spectrum sharing as an alternative to sort of the exclusive licensing that is what allows, big mobile carriers like Verizon and AT&T to dominate their industry segments.
There's a lot of things that I want to jump in with. I think one of the ones that comes to mind is a quick question, which is, there's all these devices that people want to buy now are wireless, increasingly. Mm-hmm. And a lot of people, myself included, are saying, look, the future is going to be wireless, but to get there, we need a lot of fiber as well, fiber optic connections. And I'm just curious if you can explain to the audience why that might be, if you agree with us.
Oh, yes. I mean, that's... In fact, I wrote a report maybe 2 years ago explaining why the wireless future that we envision, must be built on a high fiber diet. And the reason is that if you really want, those three outcomes I mentioned, wireless connectivity for devices, like smartphones, tablets, laptops, if you want all that to be available everywhere, high capacity, and especially if you want it affordable, you can't do that over the expensive licensed spectrum and through carrier infrastructure because you have to pay through your nose. There's bandwidth caps, there's high pricing, and so what people are just almost naturally turning to is Wi-Fi, as an alternative. And right now, I think most people don't even realize that at this point, roughly 60% of all the mobile data traffic, all the broadband traffic that goes over mobile devices like smartphones, is not actually going over licensed spectrum through carrier towers. It's going a very short distance, 100 feet or so, over unlicensed spectrum into a wireline network that's already been provisioned for other purposes, for, at home, at work, at Starbucks, maybe a community network. And so that trend will increase because the more deeply we penetrate fiber everywhere, the closer you'll always be to a wire, and the more unlicensed and shared spectrum the public has access to, the more ways that it can get into those wires over the air without relying on the carriers.
One of the things that just came up in terms of licensed versus unlicensed is this the really horrible train accident, the Amtrak accident just north of Philadelphia. And you wrote an article, which is what reminded me that I really wanted to bring you on the show, along with Patrick Lucy, who couldn't join us today, but is with the Open Technology Institute as well. And in it, you talk about how Amtrak had been delaying implementing some of the safety technology because they really wanted this licensed technology. And in fact, they could have been moving ahead with an unlicensed approach. So maybe you can just sort of explain the difference between licensed and unlicensed in those terms.
Well, what happened with Amtrak is that 7 years ago, Congress mandated a safety technology called positive train control. This was part of the Railway Safety Act. It would automatically slow or stop a train once it exceeds a speed limit, such as ahead of the curve where the Amtrak train jackknifed off the rails north of Philadelphia. And positive train control is based on a series of beacons and sensors that where the train is, it's going communicates, with the railway infrastructure and the safety infrastructure all along, the railroad right of way, through wireless connections. So the question was, in implementing this, what spectrum, in other words, what airwaves would the railroads use? And so they decided to ask for this extremely expensive television band spectrum. A fairly small amount, but spectrum that is so prized that at the auctions that are scheduled for next year, the Federal Communications Commission expects that the wireless industry will pay roughly $1.5 to $2 billion for that much spectrum, and they wanted to have that just to connect along the rails. So Congress wasn't giving it to them. The FCC was prohibited by law to just give it away because the law requires that it be auctioned.
And to be clear, this would be spectrum that only Amtrak would have and nobody else would be able to use under any circumstances, right?
Right. This would be exclusively licensed spectrum, meaning that only one company could use it in a given geographic area. So this licensed spectrum, they really only needed it in a very specific place and not even at high power. It's just along the rail lines. And yet they were looking for this very expensive spectrum, which is licensed over huge areas and which is, as I said, is probably valued at $1 to $2 billion nationwide. So since the FCC was prohibited by law to just give it away to these private rail companies, the FCC's advice was, well, go to the secondary markets and negotiate, leases or to purchase the licenses from other parties that hold this spectrum, utilities and others. So the freight railways formed a consortium and more or less did that. But Amtrak didn't have the resources, and there's just a lot of problems with the secondary markets. So 8 years later, they had just barely, gotten hold of the spectrum and still had not deployed the positive train control system that would have avoided the crash. An alternative, what we write about in the article, is that increasingly industries like that, like utilities, healthcare industry, and others, are finding that shared spectrum is much more plentiful and economic for even for critical uses. So, for example, a majority of wireless monitoring of patients, of healthcare patients, is done over unlicensed spectrum. And unlicensed spectrum is spectrum that's simply bands of frequencies that are left open for shared public use at lower power. The U.S. leads the world by far in the deployment of smart grid and automated smart meters because they're using unlicensed spectrum rather than paying for that connectivity from mobile carriers. And in industry after industry for inventory control and so on, there's an increasing move toward using this unlicensed shared spectrum. But the mentality remains, among some industries, and the railroads were on that list, the mentality that they need to have exclusive licenses so that they have absolute certainty. But right now, that spectrum is really not available except at extraordinarily high prices and often after long delays, as we saw in Amtrak's case.
I think there's a good public policy question, which is, of the best spectrum that we have available, should we be devoting slices of it to just one technology when you could be sharing it? I mean, I come back to actually the thing you started off with in noting that some 60% of our smartphone traffic goes over Wi-Fi. I think if you went back 20 years ago and you told people in 20 years, everyone's going to have these handheld devices, they're going to be able to communicate, they're going to be able to share thoughts with anyone in the world, and all of this is going to take place on just these narrow bands that we consider to be junk. People would probably think you were crazy.
That's right. I mean, the old approach was command and control, where each industry kind of came in turn and got their exclusive assignment of frequencies, and that's turned out to be very inefficient because all of the good spectrum, the stuff that will travel fairly long distances or will penetrate through obstacles, is assigned to someone. And most of it's not being used very intensively. Technologies change, industries evolve, and yet all the old assignments are still there. So as a result, policymakers have been moving away from exclusive licenses toward a new framework based on flexible use and shared access to spectrum bands.
This is where we actually have just had action from the Federal Communications Commission regarding something I think you and I are both pretty excited about, this citizens band. Why don't you tell us what's going on there?
Oh, sure. Yeah. So this is like a whole nother path toward broadband abundance. One is, as we mentioned earlier, Wi-Fi. So, Wi-Fi grew up on these junk bands, on this unlicensed spectrum that was originally set aside for things like cordless phones and microwave ovens. Wi-Fi has become so prevalent that even the Wi-Fi bands are getting, crowded. But there are other much larger bands of spectrum, particularly those being used by the federal government, the military in particular, where most of the capacity is unused. And so if you have, instead of exclusive use, if you have dynamic sharing, you can unlock that capacity and potentially create bandwidth abundance. And that's what's happened now. A few years ago, I was actually part of this process to write a report for the President's Council of Advisors on Science and Technology, the PCAST. And in 2012, they recommended to the President in a report that there could be a shared spectrum superhighway across more than 1,000 megahertz of just federal bands of spectrum if it was all opened up for dynamic sharing. And they recommended that this could be done like working around the incumbents, like military radar and other federal uses, by using a geolocation database system and, in some cases, sensing. This was called the Spectrum Access System. And that there could be different tiers of access where the incumbent users, the federal agencies, they would be protected from interference, but you'd have opportunistic access by anybody else, essentially unlicensed access, as well as the option to have some priority access licenses that could be sold or auctioned for short-term use for particular industries, maybe by Amtrak.
At the recent Freedom to Connect event in New York City that David Eisenberg put on, Milo Medin from Google gave a presentation in which he was talking about the sharing, and he noted that there's bands that are reserved just for the landing system on aircraft carriers, and that you don't have a whole lot of aircraft carriers in Kansas City, so they would be able to use some of that spectrum without a threat. And if I understand it correctly, you'd have some people that would be paying for priority access, and that would be on a dynamic basis, basically on a sort of is it by like 5-minute blocks, or I don't understand how it really works at that level of detail.
And in fact, it's funny because Milo and I drafted the chapter on for the PCAST report on how this could work. And Milo's exactly right, because this Navy band was the one that the PCAST recommended be the first to be opened up for this, dynamically shared model, which the FCC adopted last month, and it's called the Citizens Broadband Radio Service. And what it does is there's 150 megahertz of spectrum that's mostly dedicated to the Navy, but they only use it offshore.
Right, and 150 is an incredible amount, right?
Oh yeah, that's about as much or more than any of the national mobile carriers have, for their networks, and this would be now available for shared use. There will be a passive sensing network set up, some sensors set up along the coastline to detect if a ship comes close to shore with its radar on. If it does, the devices will be told to get off, those particular channels that the ship is using. But other than those situations, and across the entire inland part of the country, that 150 megahertz will be available all the time. And it will be available, a majority of it, 80 megahertz of it all the time for unlicensed use. They're calling it general authorized access, was the FCC's term for it. But then there also will be as much as 70 megahertz available for priority access licenses, or PALs. And what these are 10 megahertz licenses that companies could acquire for, they're essentially 3-year non-renewable licenses, which is much shorter term. Today, licenses are wide area. They're typically for 8 or 10 years, and they're automatically renewable. These would be non-renewable, would be shorter, much shorter term, and are for much smaller land areas. The PCAST actually recommended much more of a Google ads market approach, where essentially it would be like a spot market.
That's what I was thinking, right? That's what I was. Thinking of.
Exactly. Like the idea was that if a hospital campus needed to know that they had quality of service for some particular use, they could go in and just buy. Essentially, you'd pay for interference protection in just a very small area where you really need it. But the FCC thought that initially that was too difficult to administer, so what they sort of jerry-rigged the traditional system to make the license areas very small, the license terms very short, and non-renewable. Eventually, though, once the spectrum access system proves itself, that we will end up with a Google AdWords type of, auction system where you just get, the rights for the short time and place you need it.
So there's so much more detail that I'd like to go into, but I want to keep this at a reasonable length. And I'm curious, a lot of us envision a future, or we want to envision a future where neighbors can get together, or entire neighborhoods, and build a wireless network with off-the-shelf parts that would not be very difficult to build. And we've been hoping that some of these these new spectrum approaches would enable that. Is that the kind of thing you think we can hope to move toward?
Well, I think these new trends toward opening far larger bands for unlicensed shared public access, as well as these dynamically shared bands, such as the Citizens Broadband Radio Service, taken together we will have, I think, transformed what's perceived to be spectrum scarcity into spectrum abundance, meaning that, for communities, there will be plenty of wireless capacity there that will be free for the taking. And then it just becomes a question really of the equipment and in a sense, what you might call the business model. It's really interesting. I think many people assume that the main obstacle is spectrum because they see, for example, there was an auction in January this year that raised a record of $41 billion for about 50 megahertz of spectrum for about a third of what the Citizens Broadband radio service is opening. So the assumption is that it's spectrum that's scarce, but spectrum isn't scarce at all. Less than 20% of the best spectrum is even in use. So once we open it up for this dynamic sharing and have more unlicensed, more opportunistic access, spectrum won't be the obstacle, but there will still be challenges as far as getting equipment on a scale, that makes these sort of networks affordable, and then getting the political will, to put them in place.
Right. I think that's something sometimes people may not have realized, which is one of the reasons Wi-Fi is so successful is because there's such a large market for it. And if device makers aren't convinced there will be such a large market, then they're not going to be developing the machines, the technology in the right way to enable that outcome. Right.
Yeah, Wi-Fi is premised on the economics of the Internet, in effect, where the investment is at the edge, by individuals, and it's all very incremental and affordable. So just as, you expand the Internet every time you attach a new server in a new location, Wi-Fi is similar because you attach a router to a wireline connection and then broadcast connectivity. So what's really going to be needed in the future is just to try to extend the logic and the affordability of Wi-Fi to these community networks, so that instead of separate hot spots, you have true, in a sense, hot zones of mesh networking, and there are examples of that. I mean, our Open Technology Institute has been working with communities to build out these networks in some low-income areas in Detroit and Philadelphia and Brooklyn, and Mayor de Blasio in New York is working with us on this new RISE program, which it's also based on neighborhood resiliency, where they were going to be working with them to build out community Wi-Fi networks that can withstand a hurricane, because that was the initial effort in Red Hook, part of Brooklyn. So these are all really exciting developments, and hopefully as communities realize that the spectrum is there for the taking, that there will be more efforts like that.
And I think we end up back where we started with, there's a lot of promise for future spectrum as long as we continue to see the federal agency, the Federal Communications Commission, manage it correctly. But communities should be preparing by getting fiber deep into their neighborhoods so that they can make sure they have a lot of areas where they can connect these nodes, and we'll see what happens.
Yeah, and also by opening their public fiber, because many communities have fiber that's been put down for various public purposes, iNets, school nets,
right, traffic signals, all kinds of things.
Right, and often there's excess capacity there, and if that was open, it would spur not only more community networks, because as we said earlier, Wi-Fi in a high fiber diet is much more potent, right? As long as you're close to the wireline backhaul, and that's fairly inexpensive, you can put a cloud of connectivity over a neighborhood. So more fiber access to it will have more spectrum. So the pieces are coming together. We just need to find, in a sense, the right recipe to navigate around the economics and the politics.
Right. Well, thank you so much for taking the time to come on the show and talk with us about these issues.
Yeah, thanks, Chris. This was great.
Send us your ideas for the show. Email us at podcast@muninetworks.org. You can follow us on Twitter. Our handle is @CommunityNets. If you use Facebook, be sure to like our Community Broadband Networks page. Thank you again to Person for the song Blues Walk, licensed through Creative Commons.